Okay, so this is right from the textbook, and I wanted to back up a little bit from where we were looking at it last night, yesterday afternoon. And with these first kinds of questions, you're asking us what angle has this for an answer, like for the sine. So, like if I look at number 3 here, okay, it says find the arc sine of negative 1/2. Well, that tells me that some angle has a sine. So here's what they're writing. They're saying the angle we're looking for, that's the answer because it's an angle. Find the arc sine of negative 1/2. So, well, the arc sine's confusing. So what we can do is we can rewrite this in terms of taking the sine of both sides of this, and we can say find the sine. What angle has a sine of negative 1/2? See how I took the sine of both sides? That canceled out the arc sine. So the other thing is actually, if you look at the unit circle, there's actually 2 places where the sine's negative 1/2. It's down here in quadrant. If you look at the points there, you'll see one place where it's negative square roots of 3 over 2, negative 1/2. And then over here, there's another one. What is that? That'll be positive 3 square roots of 2 and negative 1/2. Okay. Now, the other thing you got to remember from anything you looked at before is that arc sine only gives us output in quadrant 4 and in quadrant 1. So what the answer this is looking for is whatever angle this is, starting from the positive x-axis. I'm sorry, I lied to you. We're looking for this angle here because it gives us from negative pi over 2 to positive pi over 2. So what angle has a sine that's 1/2? Well, first off, we know it's the negative because it's down here. And then we ask ourselves, what angle has a sine of 1/2? Well, that works out to be 30 degrees, or pi over 6, if you're talking about radians. That's what they're asking us to do this in radians, okay? And because this is a negative angular rotation, the answer is negative pi over 6. All right. How about something like, here, let me stop this video for a minute, and I'll do number 5. Okay, for number 5, and I just decided to write it arc cosine just to shake it up a little bit. I honestly like writing arc cosine better rather than cosine to the negative 1, because that way people don't think reciprocal, they think the inverse. So same deal, let's do the cosine of both sides so we can simplify this a little bit. So the cosine of theta equals 1/2. So then what you got to remember, and that same thing with this last one, is that in a 30-60 right triangle, 30, 60, 1. This side is half the hypotenuse, and this is half the hypotenuse times the square root of 3. The side opposite the 60-degree angle. So what angle has a cosine that's 1/2? Well, that's the adjacent over the hypotenuse, so that's going to be a 60-degree angle, or pi over 3. Notice it's a different answer from this. That's because we switched angles. Here it's a 30-degree angle, and now we're concerned about the 60-degree angle. Okay, and we can take this, beyond, and most of these are actually unit circle kind of answers. One thing I do want you to remember, though, is recall that the arc cosine gives us output in quadrant 1 and quadrant 2. So positive angles between 0 and pi, or 0 and 180. Arc sine gives us output from negative pi over 2 up to positive pi over 2. And if you don't remember why, go watch my video, my flipped classroom video about that, and I showed you the graphs. Okay, so that's these basic ones, and I want to point out to you. Remember how if the cosine's 1/2, it's a 60-degree. Arc cosine of 1/2 is 60 degrees. The arc cosine of 1/2, the arc sine of 1/2 is 30 degrees, or pi over 6. That'll be important for that one that I got stumped up on last night. So now we've got these composite functions. It happens to do the sine of a cosine of an angle and find the sine of it. Well, let's talk about 19. So let's see. So I know pi over 4 is up here in quadrant 1. And on the unit circle, that would be 45 degrees, or pi over 4 degrees. So that means that's also 45 degrees. And it worked out that this is square root of 2 over 2, or 1 over the square root of 2. All right, rationalized. Now, if I'm looking for the cosine, so I'm going to break this piece up. I'm asking myself, what's the cosine of pi over 4? Well, that's the adjacent side, or x, over the hypotenuse. So that's equal to the square root of 2 over 2. Then they're asking us, now find the arc sine of root 2 over 2. Well, because this is a 45 isosceles right triangle, that arc sine will also be, see how the arc sine, the sine of this angle here, pi over 4, 45 degrees, is root 2 over 2 over 1. Same answer. So that would be pi over 4, or 45 degrees if you wanted to. They aren't specifying. All right, so they kind of undo each other. This also happens, well, actually, it would be good to shake this up a little bit. Sure. Let me choose one that's not on this paper. In this case, when I'm doing the arc sine of the sine, those are inverse operations for the same angle. So these in this case is going to cancel each other out, because we know the sine of pi over 4 is the square root of 2 over 2. And then I want to find the arc sine of root 2 over 2, which is pi over 4. Do you see how they cancel? Pi over 4, sorry. See how that got canceled out? Now, where it gets a little tricky, because arc sine always gives output in quadrant 4 and in quadrant 1. So from down to negative pi over 2 to positive pi over 2, where this can be a little dicey unless you remember that fact, that that's where the output's coming from. And it plays into what's going to happen here in 21. If I ask you to find the arc sine of the sine of, well, let's do 4 pi over 3. Okay, I know if I look at the unit circle even, I know that 4 pi over 3 is down here in quadrant 3. I know the reference angle is pi over 3. I know the sine's negative down here. So what's the sine of 4 pi over 3? That's the same as the negative sine of pi over 3, which works out to be square root of 3 over 2. Okay, so this expression part here is the square root of 3 over 2. So now I'm asking to find the arc sine of root 3 over 2. And actually it's negative, I'm sorry, negative root 3 over 2. Because it's negative here, I dropped the ball there. So now what's the tricky part is, we need to remember that arc sine gives us output in quadrant 4 and quadrant 1. This is over here in quadrant 3, so they're not going to cancel each other out. It's got to be over in one of these two quadrants. So it's a negative angle, it's a negative sine. So that tells me it's got to be down here for a negative angle, because that's we're sine. Remember, all the trig functions are positive up here. Only the sine's positive here, the tangent's positive here, the cosine's positive here. And this is an arc sine, so what angle has a sine? So what angle has a sine of negative square roots of 3 over 2? Well, it worked out to be negative pi over 3. So do you see how it's not giving us the 4 pi over 3, but it is giving us negative pi over 3 as an answer, okay? Because that's this angle right here. I know it's confusing. Let's try number 21. So 21 asked me to find the cosine of 4 pi over 3. Of course, I kind of was just working with that. So I know that's down here. I know that's a 60-degree reference angle. This is the square root of 3 over 2. That's 1/2. And of course, both of these are negative over here in this quadrant. So what's the cosine of 4 pi over 3? Negative 1/2. Then they're asking me, find the arc sine of negative 1/2. That's equal to the angle. So we're going to say, what angle has a sine of negative 1/2? And we know, because of arc sine only has output here, and the only way sine can be negative is if it's down here in those two quadrants. So if this is 1/2, this has to be the square root of 3 over 2 side. This has to be 30 degrees, or pi over 6. See how it switched angles? It switched angles because we were working with cosine. Now we went to the sine. And that's positive. The arc sine, no, the angle is negative pi over 6. Sorry, because it's down here in quadrant 4. So it's going to be negative pi over 6 would be that answer. Okay? Little tricky. I hope that makes better sense than what I was stumbling around with doing last night. We can do some more if you want. Now, these last couple on this page, notice how they switch in the arc sine position or the inverse trig function position and the regular trig function position. So in this case, what we want to do, and this is where my other video that I went through, I said, well, let's not use y, let's use theta. So I know some angle. I'm talking about this one. I know some angle, the sine of some angle is equal to 3 over 7. And that's the opposite, that's the hypotenuse. They're both positive, so I'm going to assume they're up here in quadrant 1. They don't tell us actually anything else, so we can certainly just assume that. And the opposite side is 3, the hypotenuse is 7. Because now what I've got to do is I've got to find the sine of that angle. I don't really even need to find the angle. I just want to know the sides. So I see a right triangle. The hypotenuse is 7. The radius is 7. The opposite side is 3. To find this side, I'm just going to use the Pythagorean Theorem. 3 squared plus x squared equals 7 squared. So that's 9 plus x squared equals 49. X squared has to equal 40 because I subtract 9. So x equals, we could have a plus or minus square root of 40, but because we're here in quadrant 1, we know we're going to have a positive square root of 40. So what's the cosine of this angle? The square root of 40 over 7. And yes, we could do a little bit more. We could think of square root of 40 as square root of 4 times square root of 10, and that would give us 2 square roots of 10 over 7, but there's nothing wrong with that answer either. Okay, so see how it's a little different? It's not quite the same as what we did before. And number 25 is problematic because there's only a number there. It's not a fraction. So let's talk about what's happening with that. So they're looking for the cosine of the arctan of 4. So let's say the tangent of some angle equals 4 over 1 is the part that they didn't tell us to do. Okay, so since tangent is opposite over adjacent or y over x, this is 4, this is 1. And to get the hypotenuse, we'll just use the Pythagorean Theorem, which 16 squared, or 16 plus 1 is 17, so this is the square root of 17. Then they're asking us to find the cosine of this angle. Well, here's the angle, so 1 over the root 17 would be that answer. And of course, you could then rationalize it to the square root of 17 over 17. Because we're multiplying, right? We're multiplying by root 17 over root 17, a form of 1. Okay, I hope this helps with finishing up that homework.